We measure it, we obey it, we fear running out of it, but what if everything we call time, the seconds ticking away on a clock, isn't time at all? What if it's only the shadow of something deeper? Like the difference between weight and mass, what we measure may not be what's actually there. To find real time, we may need to stop chasing the illusion. What we call time isn't a substance, it isn't even a thing, it's a measurement, a way to compare the rate of change between events. A second isn't time. It's the oscillation of a cesium atom 9,190,000,000 times. We've mistaken the measuring stick for the fabric itself. In truth, what we track with clocks is change, the unfolding of one state into another. We live in relationships between events, not within an absolute stream. Think of weight and mass. For centuries, they were used interchangeably until Newton showed us the truth. Mass is the quantity of matter. Weight is the force of gravity acting on that mass. They feel the same, but they aren't. On the moon, your weight changes. Your mass does not. The same mistake is happening with time. We confuse our measurement of change with the thing itself. Measured time is like weight, it's contextual and relative. Real time, if it exists, is like mass, a constant foundation. That's the real question. Is time something that exists on its own, like space, or is it emergent, something that arises from deeper physical processes? Many leading physicists now suggest time is not fundamental at all. It's a pattern, a rhythm that comes from change, entropy, and quantum relationships. Our clocks don't measure time, they measure how systems evolve relative to others. Maybe time doesn't flow, maybe it doesn't even tick, maybe it emerges from the structure of information itself. In the 1600s, physics couldn't solve motion or inertia because it lacked a concept of mass. People used weight in equations and hit walls. It wasn't until Newton introduced mass that things changed. Today, we're in a similar place. Relativity says time is relative. Quantum mechanics treats it as fixed. The two models don't agree, and our deepest theories clash at their cores. Could the confusion come from using the wrong tool? Are we calculating physics with clock time, when what we need is a concept of actual time? So how do we find it? How do we discover what time truly is? We may need to stop measuring change and start identifying what's invariant, what doesn't depend on the observer. First, look for frame-invariant properties. Clocks change under gravity or speed, but maybe there's a deeper rhythm that stays constant across all frames. Second, go below Planck time, where our current math fails. Perhaps actual time exists beneath that boundary, beyond the reach of measurement, waiting to be derived from quantum gravity or spin networks. Third, consider that time may be information flow, not a dimension, but the order of events in a universal computation. If the cosmos is a quantum computer, then actual time may be nothing more than the clock cycle of its code. Finally, there's consciousness. Neuroscience tells us our perception of time is elastic. Time flies when we're focused. It slows when we're bored. Could our brains be producing time the same way clocks do, by comparing change? If so, consciousness might not be a distraction from discovering time. It might be the key. To go further, we may need more than science. We need a shift in perception. Stop thinking of time as a flow, stop picturing it as a line. Instead, think of it as relationships, as rhythm, as causality, as a script that unfolds not over time, but as time. We may never find a thing called time, but we may find the grammar of the universe. And in doing so, realize we've been reading the clock wrong all along. Measured time is not time, it's a tool, a ruler used to track motion. The real thing, if it exists, may be hidden beneath, or it may be something we generate with every breath, every thought, every quantum vibration. But either way, we're on the edge of discovery. Just like mass changed physics forever, redefining time could change everything. We may not discover actual time with a better clock, we may discover it with a better question. Time may not pass, we may simply change. Subscribe for more explorations into the mind, physics, and the nature of reality.